So there aren't very many examples in the book, really. These take a while to do, plus they take, paper. But I wanted to give you one more example. Now, we've done some where we were able to solve the system and there was just one ordered triple that satisfied the system. That's kind of in some ways, our preferred option, right? We're looking for that one point that'll satisfy all three equations. But then we also did a system where there was no solution. Those ones go pretty quick. And then the dependent solution, that was in the last video. That's a little bit trickier because you have to get the solution, the ordered triple, in terms of one of the variables. Okay, so that's just kind of a recap. So we'll see what this problem does. Okay, now how am I going to know which variable to eliminate? Well, it's kind of up to you. There are like three places, like here's x with a coefficient of 1, here's y with a coefficient of 1, here's z with a coefficient of -1. So, you could really pick any of them and it's going to be about the same amount of work, what you want to simplify or eliminate. So I'm going to go ahead and go with x, just because. And so I'm going to multiply the bottom equation by -2. So my top equation, I'm going to copy that down. So you might be saying, well, why did you pick -2? Well, I'm looking ahead. I'm trying to eliminate that 2x in the top equation, and so I'm going to have 2x plus y minus 2z equals -1. Now in the bottom equation, when I multiply by -2, I get the -2x. That's what I wanted to have happen, a 2x and a -2x. And then I have plus 4y minus 6z equals -12. So you really want to take your time and double check your multiplication, double check your signs. Okay, I think that looks okay. And then I'm going to add these equations. X is going to drop out. So I'm going to have 5y minus 8z equals -13. Okay, so now I need to come up with another yz problem. Well, maybe it'll be easier if I just copy down I'm going to use the bottom equation and the middle equation. So maybe it's easier if I just copy those down. 3x minus 3y minus z equals 5. And I think I talked in the first video about having a system, like how are you going to write this out? You'll have to decide what your best system is. So I'm just taking before I multiply by -2, the original. X minus 2y plus 3z equals 6. Okay, now it looks like if I multiply that bottom equation by -3, I can get the x's to eliminate. Remember, I want to eliminate the same variable. I need another yz equation. So I'll copy down the top equation, or it's now the top equation. 3x minus 3y minus z equals 5. And then the bottom equation is going to become -3x plus 6y minus 9z equals -18. Sometimes there's a tendency to forget to multiply the constant. Don't forget to multiply that. Okay. So we'll add these equations, and what do we get? The x's drop out. 3y minus 10z equals -13. Okay, so now I have this equation and this equation. You'll notice that you don't have any of the coefficients being 1 on the variables. So that means I've got to I'm going to recopy these. Okay, 5y minus 8z equals, I think it was -13, yeah. And I have 3y minus 10z equals -13. Kind of unusual, they both equal -13. Okay, I'm going to eliminate the y's, just because they're in front. You could eliminate the z's, it's probably just as much work. 5 and 3 is smaller than 8 and 10, so maybe it'll be a little bit easier. So I'm going to multiply this top equation by -3. I'm trying to get a 15, or a -15y, because 15 is the number that both 5 and 3 go into. It's the smallest one. So I have to multiply the bottom equation by 5. So in the top equation, I'm going to get a -15y. And in the bottom equation, I'm going to get the +15y. Okay, but let me finish distributing up here. So I get -15y plus 24z equals 39. In the bottom equation, I get 15y minus 50z equals, let's see, negative 65. Now, you might say, well, I didn't really want, those big numbers or whatever, but the larger numbers are helping us avoid fractions is what it helps us do. Okay. So if their answer is going to have fractions, it won't pop up till the very end here. The y's cancel out. 24 and negative 50, that's going to be a negative 26z. And then 39 and negative 65, what's that? Negative 26? Hey, I like the looks of that. Okay, so that worked out nicely. Again, you could use a calculator to go 39 minus 65. All right, let's see, anything else I want to say on that? No. Divide by negative 26. And we get z equals 1. Great. We know z is 1. Now we have to go to one of our yz equations. So which one do we want to go to? Let's go to the one I have a little dot here by. So 3y minus 10, but now we know what z is, 1. So we're substituting the z value in, the z that we got. Okay, so that gives us 3y minus 10 equals negative 13. I'm going to add the 10. So I get 3y equals negative 3, divide by 3, and I get y equals negative 1. So now I know what y is. Okay, I just have to find an equation that has all 3 variables. So I think I'll use the one that I can see, this one right here. So I'll say 3x minus 3y minus z, I'm just copying it down, equals 5. Of course, every time you copy it, you want to double check and make sure you're copying it right. And now I can plug in, I don't know x yet, but I can plug in z and y. So minus 3 times negative 1 for the y, and then minus 1 for the z. Okay. So remember the subtraction signs are already in here. So I put in negative 1 for y, but I put in positive 1 for z. Okay. So we get 3x plus 3 minus 1 equals 5, or 3x plus 2 equals 5. If I subtract 2 from both sides, I get 3x equals 3. And I get x, scroll a little bit, x equals 1. So this one was kind of different, I guess, because I got 1, 1, and negative 1. But I have to put them in the right order. So remember, it has to go x, y, z. This is an ordered triple, so it makes a difference what order they come in. 1 was x, y was negative 1, and z was 1. So that's the solution.